Hey there, in this video we're going to learn a little bit more about arrays. In particular, we're going to learn about the importance of an arrays type. So unlike a list in Python, where each element can be a completely unique sort of object, in NumPy everything in the array has to be the same kind of object. This is required for it to have the quick speed that we saw in the earlier videos. So the price we have to pay is everything has to have the same type. So let's look at an example. Let's say I have a list 1, 2, 3, 4, 5. And let's compare that to an array. I've already imported NumPy, so I can do np.array, and I can build it out of, say, another list 1, 2, 3, 4, 5. And so these two things might look like they're basically the same. But let's look at what happens if I change them. So if I change the first element of L1, and let's say I want to set it to 9.9, and I change the first element, or the 0th element, of the array, and I set that also to 9.9. Let's see what happens if we print each of these. So let's print L1, and here I'm going to print A1. So L1 does exactly what you'd expect. The first element here has been replaced with 9.9. But something different has happened to the array. When I change the first element to 9.9, it's instead showing up as 9. In fact, if I look at the other stuff in here, these values are all integer values. Because what has happened is A1 is considered to be an integer array. It's an array of integers. And that means I can only put integers into it. I suppose one possibility would have been for the computer to throw an error message at this step, but instead the choice was made in the development of NumPy to just try and convert whatever you're feeding to the array into an integer. So when you convert 9.9 into an integer, what you end up getting is 9. So that's exactly what has happened here. In fact, we can investigate a little bit more carefully by inspecting the array, looking at the array's dtype. You see the dtype, which stands for data type of this array, is int32, which means it's using 32 bits to store an integer. So not only is the type fixed for NumPy, but the amount of storage used is fixed for NumPy. In fact, NumPy will try to reserve computer memory that is all in a row to hold the contents of its array. That's a little bit different than a Python list. A Python list doesn't necessarily store 1, 2, 3, 4, 5 next to each other in the computer's memory. It just stores references to those values. And the actual location of 1, 2, 3, 4, 5 could in principle be anywhere in your computer's memory. Whereas the array tries to put everything all lined up. Again, this is part of what makes it fast. So let's say I want floating point values in my array, because if NumPy only did integer values, we'd be in a lot of trouble. So that's easily fixable. Let's just copy this here. And let's make an array A of floating point values. I can do that by just adding a second element over here. Now let's look at the documentation of NumPy just to see what's going on when I type in float. I could open up my contextual help, but in this case I want to do it just a different way. I'm going to hit Shift Tab a couple times, and we get the same documentation popping up in a little box here. In particular, I want to look at this beginning part here. Object is what we're making our array out of, and then dtype, the data type. We can set it to be whatever we want. We have some other options here that, in my experience, I've actually never had to use. Okay, so the data type, we tell it what type we want to use, and these are things like int or float, or possibly complex if you want an array of complex values. There's also some fancier codes if you want to specify exactly how many bits it has, like 32 bits versus 64 bits, that in practice you really, for our purposes, will never have to get into. So float or int, or maybe complex. Okay, so now if I create array A and make it floating point type, and let's print A and let's print the dtype of A. That should be a dot. And there we see 1, 2, 3, 4. Notice it's giving us this decimal place, really emphasizing that these are floating point numbers, and the type here was float with 64 bits. Again, we're not really worried about the number, but that the type is a floating point number. So now let's look what happens if we start mixing arrays of different type. So we made A an array, 1, 2, 3, 4, 5, that was made out of floats. Let's make B and make it out of integers. By default, NumPy will look at what values you put in here and try to make an array that matches. So if I'm being really explicit, I have to state the D type, but by default, this would have made an integer array, just like we had at the very beginning. And the reason for that is all the values typed in here were integers. So this is actually kind of extraneous. Along the same kind of lines, I could have added at least one decimal point anywhere in here, so I have at least one floating point value, and that would make a floating point array for me. So if I drop that and have at least one floating point number in there, we'll see that is another way to make a floating point array. Okay, so nonetheless, I want to make an array B. That's an integer. A has floats. Let's look at what I get if I add A to B. So if I add A to B, I get a floating point array. In fact, we can be really explicit just to make completely sure. We'll print array C and we'll print the D type. Sure enough, the result is a floating point array. So NumPy will automatically promote your result to be whatever the most general type you've put into it. Just like if I add an integer to a floating point number, Python will give me a floating point number. Same thing here with the arrays. Now, one dangerous thing that you might be tempted to try, let me just tell you, don't do this, it won't work, is you might feel tempted to change the D type of an array after it's already been created. So if I say, I want to make the D type of this array be an integer, you're in for a bad time. Because let's look at what happens to see if I do that. And it looks like what has happened here. So changing the D type of an array after it's been created really is going to break things for you. Because what happens here is that NumPy reserves some big block of computer memory and it stores values in it with a bunch of bits, ones and zeros. And separate from that, it keeps track with this variable D type with how am I supposed to interpret these ones and zeros. And if you change that, you don't change the underlying patterns of ones and zeros, you just change how NumPy will try to interpret it. And so what happened here is the patterns of ones and zeros that give you these floating point numbers, 2, 4, 6, 8, 10, when you try to interpret those patterns of ones and zeros as integers, you get some very surprising looking results. So that's why you never want to change the D type of an array after the fact. You want to create your arrays with the right kind of D type to begin with. So usually that means having explicit data that is in the right kind of form, or if you want to be sure, or if you can't really control what the data is going to look like, using a D type built into the call here like int or float. Okay, so in this video we've looked at the types of arrays and why that matters, and how the types of an array has to be consistent all the way through, element by element.